Good afternoon. So I'd like to share with you some information on how we can use data analytics to achieve a more sustainable future. Really the goal, the main thing that's going to happen is we're going to use less energy. That's really all that it is. All the other stuff that I'm going to say is going to roll into that. So just keep that in mind. And so two things that the analytics are going to help us do. One is ensure that our systems and buildings are operating the way that they should, so we're going to be keeping them at peak efficiency. But then also, it's going to radically change our operations and maintenance strategies that are currently in place. So with that, it's going to help us become less reactive and more proactive. We want to get away from reacting to building issues that could have been prevented. So we want to get more proactive, and we want to get data-driven, targeted actions, and really eliminate those faults before they happen. So not only will this increase the efficiency of our building, but it will also increase the efficiency of our operations as well. So before we get into the analytics part of things, I'm going to go over a brief understanding of what we're talking about. We've already talked some about IoT, Internet of Things, and what Jeremy said earlier, it's the things, it's the devices. This is the connected network of devices, and the exchange of information between the devices is key to increasing efficiency. The more we communicate, the more efficient we'll be. So the popular examples are like your Nest thermostat or a Tesla Roadster, connecting it to a central database. And then the next thing is big data, so large amounts of data. We want to connect and collect from every one of those devices, and it just becomes a massive amount of data. These are such large data sets that they cannot be analyzed with traditional or regular software programs. You need custom applications. So after connecting and exchanging data via Internet of Things, big data is that mountain of data that is now there that we need to go through. So that leads right into the analytics. And that's what we're going to talk about today. So this is where we will pour through the mountain of big data and determine the information that needs to be acted on. So really simplifying it down, this is our smart building. I'll just say it in plain words. We want to first connect and collect, get data from our building. Second, we want to organize and analyze that data and get the valuable information. And then third, really the most important piece is take action. Now that we've got that information, that key targeted data-driven information, we have to act on it, because otherwise nothing's going to improve. So now I want to go over the basic infrastructure of a general smart building in today's society. So first we have at the very bottom level, it's the things, the devices. We have the sensors, the CO2 sensors, the thermostats, the lighting, the power meters, utility meters, water meters, all of those things. You really have to invest in those sensors because they're what we're building everything else on. So then the second level is the building management systems. Those are the systems that are at the building level, and they integrate and manage all of the devices, making them work together. And what we're going to do with the data analytics is commission those systems, making sure that they're doing what they're supposed to do. And so that's really the third level. And that's in the cloud, and it's the building management level. They don't really, their main goal is to integrate and operate all of the devices. It's not really to do advanced data analytics. They don't necessarily communicate with other platforms. What we can do with the cloud platform is integrate multiple buildings, multiple platforms, get all the data to one central source, and then run advanced data analytics. So now we'll kind of go over the progression of analytics. So really what we want to do is, at the bottom you see the reactive culture. We want to get away from that. That's, incredibly inefficient. We're just reacting to problems as they occur, not getting ahead of the issues. So what came next? It was the preventative culture. Think like changing your oil in your car every 3,000 miles, or changing your air filter in your AC unit at home, which you should all probably do when you get home. Little reminder. Because it's important, it'll make your unit more efficient. But those things are not really like analytics based. They're just preventative. It's you're helping, but you're not really doing any kind of analytics. So the next level is what's widely available today, and that's condition-based analytics. So that's where we write rules and advanced scripts, and it looks at the data. It goes through that big data source and finds bad conditions, and then we can act on those. We can eliminate those bad conditions before a major fault occurs. Okay, so it's good. This is very helpful, and it will save you a lot of energy. What we want to do next is get to more predictive, even more predictive. We want to get to systems that use machine learning and artificial intelligence to predict the problems before they happen, so that we can really then eliminate those things before they become a major issue. And it's going to radically change the operations and maintenance schedules that are being done today. So we're going to keep them at peak efficiency. Beyond that, we have the prescriptive analytics. So that takes it even further. We want to integrate with even more data sources. Think like maintenance records, or inventory of parts, or even parts catalogs, and have all of that information available to the analytics system so that it can help us determine the right actions to take to resolve the issues. So we're going to get into an example of that later on. What I want to go to next is what we're doing today with analytics. And so the cloud-based tools that are available today, they should be able to retrieve data automatically. There's no need for manual data collection today. It should all be done automatically. The data goes up to the cloud so that it can be analyzed. Then the system should be able to monitor and analyze the operations, again, making sure that all of our systems are doing what they're supposed to be doing, and then also provide visualizations to the building management team so that they can understand, okay, this problem happened, and then they can see the data behind it. It's proof of, okay, we need to go and fix this. And then the last piece is being able to communicate and track the actions taken by the building management team. What needs to happen? What did we do? Who's got the ball in their court? Who needs to act on this next? And then I have a couple just visualizations. These are simple visualizations from an analytics platform. And what we want to do with these visuals is help the O&M team see exactly what's happening. And this is the advantage of using data analytics. Every piece of equipment is constantly being monitored. And then when something does go wrong, we're able to have this data to point like, hey, that's what's going on, and it's this piece of equipment. You don't need to just go say, hey, I think something's wrong in building 3 over there. I know exactly which room of building 3 the problem is. Go fix it. So now we'll look at how we use data analytics in practice today. So just a picture of a large university campus with multiple buildings. And so the number of data points that you're monitoring can escalate pretty quickly. So we're going to say 44,000 data points. If you have 44,000 data points at 15-minute intervals for 1 week, that's over 29 million data records that need to be analyzed, data readings. So that's the big data piece that I was talking about. You can't have one engineer go through 29 million data points. It's not good. So the process we have is, one, we want to define what we want to do with our data analytics. So we'll define our key objectives, our key performance indicators. What do we want to achieve with the data? And then two, we want to connect the devices, collect the data. Number three, we want to use data analytics. That's the next piece. Use data analytics to find the problems. And then that leads directly into number four, taking action through the use of, and so through the use of this process, we were able to reduce the maintenance budget for this campus by 20%. So that's how we're using analytics today. So where are we going? What do we want to do in the future? Now I'm going to talk about a totally prescriptive type of analytics solution. So imagine we've got an advanced AI machine learning analytics platform, and it's monitoring this air handler fan, and it looks at it and it says, yes, the fan is using more power than it typically does, so we need to dive a little deeper and see exactly what's going on. So it looks at the environmental factors, it looks at the supply temperature in the room, static pressure, and then it says, okay, those things are fine, but yeah, the fan is at a higher speed than normal, so let's look at the maintenance records. So it looks at the maintenance records and it sees that the fan belt was tightened a few months ago. So that kind of leads you to believe, like, okay, maybe the fan belt is starting to slip a little bit more. It could be failing soon. So it looks also at like the fan belt catalog information. So that fan belt that's installed, it says it's got a 5-year lifespan. The fan's been running for 5.5 years. So all of this information adds up to a likely fan failure within 3 days. So action needs to be taken, right? Clearly, what we need to do is just replace the fan belt. So it'll look at the inventory and it'll say, hey, there's no fan belt in the inventory. We need to order a new fan belt. And the system will go ahead and order the fan belt. There's a part number, and it'll notify engineering, send all of this information to the operations maintenance team so that they can then get the fan belt replaced before any kind of shutdown takes place in this critical area. So that's kind of the example of the prescriptive future that we want to get to. And then these are really just kind of the main takeaways of what we can do with data analytics as it relates to a more sustainable future. Number one, all the other things are going to roll up underneath it is lower our energy use. And we're going to do that by maintaining our peak efficiency 24/7 through commissioning of all of our building systems. We're going to be able to find the invisible issues, things that people wouldn't just be able to find if you go walk through the building. Things like heating and cooling at the same time. It feels okay in this room right now, but if we're cooling the air down too much and then heating it back up, we would never know it, and that's a waste of energy. We can avoid issues by looking ahead, using those building models, the advanced machine learning algorithms. They can build models, look ahead, use the incoming data to compare. And then we have less reliance on personnel. What that really means is less reliance on personnel having to do like advanced analysis by themselves. It's all done by the system. And then the operations and maintenance team will get better information, and then it's the data-driven actions that I was talking about. It all leads to that. It's taking the right actions, making our actions more efficient. So I hope that all of this information has inspired you guys to start using data analytics today in your buildings. Thank you.